In this lesson, we're going to discuss illustrating permutation of distinct objects. We need to discuss first 4 techniques in counting events. First, making a table. Second, using a tree diagram. Next, systematic listing. And the last is fundamental counting principles. Let's have some example situation. There are 4 cyclists in a race. In how many ways will they be arranged as first, second, and third placer? So in this situation, we're going to use the 4 techniques in counting an events. Try nating isolve yung problem a while ago using making a table. So first, ilan nga ba ang cyclist natin? We have 4. So pangalanan natin sila as cyclist A, cyclist B, cyclist C, and cyclist D. Mag-identify tayo ng possible arrangement. But remember, 3 cyclists at a time lang kasi kailangan lang natin ay identify ang first, ang second, at ang third placer. So dito may table na akong ginawa. Yung first column, hindi ito kasama sa mga possible arrangement kasi dito lang nakalagay na sa unang row, A is the first, sa pangalawang row, B is the first, sa pangatlong row, C is the first, and sa pangatlong row, D is the first. So, dito sa second column, dito nagsisimula ang mga possible arrangement natin. So, kung titignan natin sa unang row, si A ang ating first placer. So, ayan, pansinan nyo, si A lahat ang first placer. Sa pangalawang column, tsaka sa pangatlong column, si B ang ating second placer. Ayan. Pero kung mapapansin, ang ating third placer ay si C or si D. So, pinalitan lang natin ng third placer. Sa pang-4 na column at saka sa pang-5, ang second placer naman natin ay pinalitan natin na si C naman ang ating second placer. At syempre, yung third placer natin, nagpalit lang tayo ng B or D. And then next, sa last 2 column, si D naman ang ating second placer. At ang third placer natin ay pinalitan lang natin ng B or C. So kung mapapansin, 6 ang arrangement natin kapag si A ang first placer. Pag si B naman ang first placer, mapapansin din natin na 6 din ang kanyang arrangement. Same process dun sa ginawa natin kay A. Una, kailangan ma-identify mo muna kung sino yung second placer. Yan, sa unang 2 arrangements, si A ang second placer. Tapos yung third placer lang natin, pinagpalit lang natin si C at saka si D. Next naman, si C naman ang second placer at pinagpalit lang si A at saka si D. Next is si D naman ang ating second placer at pinagpalit lang si A at saka si C. So, kailangan maging systematic ka rin dito sa paggawa ng table mo para mas ma-identify mo lahat ng arrangement. So, ganun lang. So, kung mapapansin mo, sa A is the first, meron kang 6 possible arrangement. Pag B is the first, meron kang 6 again. Same with C at saka si D. So, kung ito total natin, how many number of arrangement do we have? We have 24 ways para ma-identify natin or para mabilang natin yung mga possible arrangement wherein magkakaroon tayo ng first, ng second, and ng third placer from our 4 cyclists using a table. Let's try to use naman the tree diagram. So first, yung A natin will be the first placer. Next naman, si B ang ating second placer at si C ang ating third placer. Yan yung unang arrangement natin. Next, palitan mo lang yung third placer. That will be D. So, nabanggit na lahat yung 4 na cyclist natin. Next, palitan natin yung second placer. So, siya na si C ngayon and si B naman ang ating third placer. Sunod, palitan natin ng third placer, magiging D naman siya. So, nabanggit na ulit yung 4 na cyclist. Next, palit tayo ng second placer. So, ang second placer na natin is si D at ang third placer natin is si B. And then, palit tayo ng third placer, si C naman. So, kapag si A ang first, meron tayong 6 na arrangement. Same with B, ang ating first placer. So, yung una nating arrangement, BAC. A is the second, C is the third. Next, si A pa rin ang second and si D naman ang third. Next naman, palit ka ng second placer tsaka ng third placer. Ang second placer natin is si C and si A naman ang ating third placer. Next, palit ka ng third placer, si D naman ang third placer. Next, palit ka ng second placer, si D naman at si A naman ang ating third placer. At papalitan mo ang third placer na C. So again, meron ka ulit 6 arrangement pagdating sa B as the first. Next, if C is the first, ganun pa rin, magkakaroon ka pa rin ng 6 arrangement. And kapag D is the first, magkakaroon ka pa rin ulit ng 6 arrangement. So, kung bibilangin mo, meron kang 1, 2, 3, 4 na tiga-6 na arrangement. So, it means we have 24 possible arrangement. So, using tree diagram, makikita mo agad yung mga arrangement na po pwede mong ma-create in a certain situation. Now, let's use systematic listing. So, first, meron tayong 4 cyclists. We have cyclist A, B, C, at saka D. So, sa first placer, meron kang 4 na cyclist na pwede nating pagpilian. Si A, B, C, at saka si D. Sa second placer, 3 cyclists na lang ang pwede nating pagpilian. Kasi nga, let's say, si A na ang first, yung 3 na lang na cyclist, si B, C, and D, ang pwede na lang ilagay sa second place. Pagdating sa third place, 2 cyclist na lang ang pwedeng pagpilian. Let's say, si A ang first, si B ang second. Pagdating sa third place, si C and D na lang ang pwedeng ilagay. So, yun yung magiging process natin kapag maglilist tayo ng possible arrangement. So, ito yung mga possible arrangement na pwede nating i-list down. So, let's say, sa unang placer, ayan, nakalagay si A. Tapos, sa second placer, si B. At sa third placer, si C. Next, palit ka lang ng third placer, magiging D na siya. So on and so forth. So, ang major risk lang dito is kailangan ma-list down mo lang siya or kailangan maging systematic ka lang sa paglilist para lahat ng arrangement ay kailangan mailista natin at wala tayong makakalimutan. So, all in all, meron ka pa ring 24 possible arrangement. Next, let's use naman fundamental counting principles. When we say fundamental counting principles, this is a technique in which if 2 events are independent and one event occurs in A ways and the other event occurs in B ways, then these events occur in AB ways. So let's say, sabihin lang natin na meron tayong 2 independent event at bawat event ay merong kanya-kanyang number of ways na possible na mangyari. So, ibig sabihin, let's say, A ways yung unang independent event. Sa pangalawang event naman, meron kang pwedeng gawing B ways. So, para ma-solve mo or para ma-identify mo na si A and B ways ay magsasabay or mangyayari at the same time, it means kailangan mo lang silang i-multiply. So, that is A times B ways. So, etong fundamental counting principles, ang usual na ginagamit natin para malaman natin yung exact number of ways na pwede nating ma-identify sa isang situation. Now, let's use fundamental counting principles sa pag-solve ng problem natin. Una, kailangan nating i-identify kung ilang cyclist ang pwede nating ilagay sa ating first placer. So, we have 4 cyclists ang available na pwedeng ilagay, si A, B, C, at saka si D. So, 4 cyclists. Pagdating sa second placer, let's say nakaposition na si A as first placer. 3 cyclists na lang ang pwedeng ilagay sa second placer. Si B, si C, and si D na lang. So, we have 3 cyclists para sa second event. Pagdating sa third placer, let's say nakaposition na si B, si C and D na lang ang pwedeng ilagay sa ating third placer. So, 2 cyclists na lang ang pwedeng ilagay sa third event. And then, para malaman natin kung ilan yung total arrangement or total number of arrangement na pwedeng mangyari sa ating problem, i-multiply lang natin yung 4, yung 3, and 2. So, 4 times 3 times 2 is equal to 24 possible arrangement of cyclists na pwede nating ilagay sa first, sa second, and the third placer. So, tama nga yung na-identify natin a while ago using making a table, using tree diagram, and systematic listing. Ito rin ang kadalasang ginagamit kapag masyadong marami or mataas na yung number of ways sa isang certain event para mas mabilang mo ng maayos yung mga possible arrangement. Balikan natin yung problem natin a while ago at sagutin natin itong tanong na to. Describe the arrangement of cyclists as first, second, and third placer. Is the order or arrangement important? Ano sa tingin nyo? Yes, importante ang arrangement. Kasi, ibang arrangement kapag si A ang first, si B ang second, and si C ang third. Iba ring arrangement kapag si B ang first, si A ang second, at si C ang third. Though, pare-parehas na letter yung ginamit natin or pare-parehas na cyclist, pero yung arrangement nila ay magkakaiba. Yung problem natin a while ago is what we call permutation. When we say permutation, it refers to the different arrangement of objects in a definitive manner. So, pag sinabi nating permutation, lagi lang tatandaan na yung order of the objects is very important. Take note of this, order of objects is important. Let's have kinds of permutation. So, we have the first kind, permutation of objects in a line. Second kind of permutation is permutation of objects in a circle. So, based lang dun sa arrangement yung kanilang pinagkaiba. Yung una is in the line, yung sunod is in a circle. Under permutation of objects in a line, meron tayong permutation of distinct objects at saka permutation of non-distinct objects. So, ang focus muna nating i-discuss is the distinct objects or permutation of distinct objects. When we say permutation of distinct objects, this refers to the different arrangement of distinct objects in a line. So, take note of this. In a line dapat yung kanyang arrangement. And it is the different arrangement when no objects are identical or the same. No identical or no the same objects. So, ibig sabihin, magkakaiba dapat yung mga objects sa isang arrangement. Walang parehas. So, take note kapag distinct objects or permutation of distinct objects in a line, so meron dapat naka-arrange sa line at saka no identical objects. Dapat unique sila lahat. Let's check if this one is a permutation of distinct objects. Arranging 4 different potted plants in a row. So, base dito sa ating situation, this is a permutation of distinct objects kasi meron tayo 4 different potted plants. So, no identical yung ating mga objects. At saka, arrange in a line kasi nga, arrange in a row. A row will represent na naka-arrange yung mga potted plants in a line. Next example is getting the possible arrangement of letters of reed. So, is this a permutation? Yes, this is a distinct permutation. Kasi yung 4 letters in a reed are all distinct or magkakaiba. And syempre, dahil nagbabasa tayo, yung letters of reed is arranged in a line. So, it means this one is a distinct permutation. Another situation is choosing president, vice president, secretary, and treasurer from 12 members in a club. Is this a distinct permutation? Yes, it is, because a president can't be a vice president or a secretary or a treasurer at the same time. So, meaning, meron kang 4 different officers that need to be chose from 12 members. And then, since this is an organization, we can say that it is arranged in a line. Let's try to solve some distinct permutation. First, arranging 3 different mathematics books in a shelf. So, is this a distinct situation? Yes, because we have 3 different mathematics books. And it is a line in a shelf. So, it will represent a line. It is arranged in a line. First, suppose that the 3 different mathematics books have titles algebra, geometry, and statistics. Let's use A for algebra, G for geometry, and S for statistics. So, what are the possible arrangement? We have AGS, ASG, GSA, GAS, SAG, and SGA. Ito lang ba lahat yung mga possible arrangement natin? 6 nga lang ba lahat? So, check natin using fundamental counting principles. So, sa unang slot, pwede nating ilagay si A, G, and S. So, 3 ang pwede nating ilagay sa unang slot. Let's say nakalagay na si A, so 2 book na lang ang pwede sa second slot, si geometry tsaka si statistics. And let's say nakalagay na si geometry sa second slot, 1 na lang ang book na pwede nating ilagay sa third slot, that is statistics. And then, multiply lang natin, we have 3 times 2 times 1, that is equal to 6. So, all in all, we have 6 possible arrangement of mathematics books in a shelf. Next problem, getting the possible arrangement of letters that could be the anagram of the word break. When we say anagram, anagram is a word or phrase created by rearranging all the letters of a certain word, and these letters must be used only once. So, sabi rearranging, isa-shuffle lang natin or i-arrange lang natin lahat ng letters. Tapos, lahat daw ng letters can be used only once. So, isang beses lang pwedeng gamitin. So, from the word break, so, ano-ano yung mga word na pwede nating ma-identify using its letters? Kailangan magamit daw lahat. So, we have the brake, yung brake ng sasakyan, at baker, yung gumagawa ng tinapay. These are the only words that we can create from the word break. So, ibig sabihin, ito lang yung 2 anagram of the word break. Next problem is arranging 4 different potted plants in a row. So, is this a distinct permutation? Yes, it is, because we have different potted plants, so it means unique lahat ng objects, and arrange in a row, it means naka-arrange siya in a line. So, for instance, meron tayong 4 different potted plants. So, lagyan natin ng code. Let's say, plant A, B, C, at saka D para mas maiksi yung mga letters na gagamitin natin. So, let's try to list all the possible arrangement. So, we have A, B, C, D, A, B, D, C, A, C, D, B, A, C, B, D, A, D, B, C, A, D, C, B, and so on. So, kung i-list down natin lahat sila, meron tayong 24 arrangement. Pero i-verify natin using fundamental counting principles, ilang plants ang pwedeng ilagay sa first slot, meron kang 4. Sa second slot, meron kang 3. Sa third slot, meron kang 2. At sa fourth slot, meron kang 1. So, kung mapapansin mo, pababa lang ng pababa. Kasi nga mababawasan yung choices mo kapag ka nailagay mo na yung isa sa position niya. So, pag multiply mo, that is equal to 24. So, it means we have 24 possible arrangement of 4 different potted plants in a row. Let's try to solve naman electing a mathematics club president, vice president, and a secretary from 10 members. So, ibig sabihin, kailangan lang nating mamili ng president, ng vice, at saka secretary from 10 members. So it means this is a distinct permutation kasi nga, isang tao lang ang pwedeng ilagay sa president, iisa lang din dapat ang vice at iisa lang din dapat ang secretary. So the number of possible outcomes for the position sa president, meron kang 10 possible choices. Sa Vice President, meron kang possible choices, 9 possible choices, at sa Secretary, meron kang 8 possible choices. Bakit ganun? Kasi pag nakapili ka na ng President, bawas na ng isa, so 9 na lang ang pwedeng maging Vice. Pag nakapili ka na ng Vice, bawas na ng isang choices, so 8 na lang ang pwedeng maging Secretary. So kung ilalist down natin lahat yan, napakaraming arrangement. So gamit na lang tayo ng fundamental counting principles. So multiply na lang natin kung ilang ways pwedeng mamili ng President, ilang ways pwedeng mamili ng Vice, at ilang ways pwedeng mamili ng Secretary. So 10 times 9 times 8 is 720 ways. So ibig sabihin, we have 720 possible ways of electing Mathematics Club, choosing President, Vice President, and Secretary.